Are we there? Awesome. We are live. Okay. Mm, Hello everyone. Welcome back to another stream. So it will be a quick stream, and I have some time constraint, and I only have like 45 minutes or so, so I cannot come and do my side projects here. So I thought, why don't we do something? Uh, so I was thinking, and I thought of let's implement linked list in Rust. So let's do that. And if anyone is watching currently, if I'm out and you're watching it later point of some time, like this stream, and also do leave your comments if you have any issues in this. Maybe on next stream we can resolve that, and I would love to watch your comments and all right, so with that said, let's start. So yeah, let's first understand what we are going to do. Yeah, here's linked list. So most of you would have like known what a linked list is. So as you can see on your screen, it's a Wikipedia page. For a linked list is a linear collection of data elements whose order is not given by their physical placement in memory. Instead, each element points to the next element. So you can visit this page and read all these like this description over here. So basically, like we'll implement a list, like singly linked list. Sorry. So this diagram is enough to say what a linked list is. Let me just draw it for you guys. So what happens is, let's imagine this is a node we have, right? So what linked list is, we have a node and a data, and in that node will point to some next node, right? This is a link to the next node, so that's why we call it a linked list. And the same will, it will point to some next node, and again it will point to some next node, and so on. So it will keep going, and until it ends it, let's say null or none, right? So this is linked list. You all must be aware. uh, yeah, right. So we have a node over here, this is our node, and we have some data in it, and there is a pointer to the next node. So these all nodes are linked, right? So it is a singly linked list because it is pointing in only one direction, right, until it hits an end. So this is called linked list. So we are going to implement this in Rust. Okay, so we need to figure out few things before implementing. We need to figure out how do we can like initialize a new node, kind a new or empty linked list, right? So few things to note over here. There is always a head that will initially be pointing to nothing. All right, so there is always a head that is initially be pointing to none or null, right? Let's say head. As we keep on like adding the nodes, this head gets shifted. All right, so initially we have head pointing to none or null. As soon as we add node, that heads get point to different the recently added node, right? So we will create two options, uh, push and pop. So what it does is it will add on front and remove from top, right? So add to front and pops the this linked list, right? So let's say if you want to add another node, then what will happen is this head will shift to the new node that we will add over here. Let me just show you. Let's say I want to add this node. Okay, we have some data over here and a pointer. So what will happen is, let's say I want to push this node on this existing node. What we'll do is we will add this node in front like this, and the head now will point to this. Okay, so this way so now you see we have a node added over here. The head was previously pointing to this node. Now that we have pushed a node over here, the head is actually here now. The head shifts, right? So we are going to implement this. Let's see how we can do that. So we need to keep in mind few things. So we have a node, right? Node. So let's make it over here, and yeah, so head now shifts to this. All right. uh, yeah, all right. So we need to figure out a few things before implementing. And what are those? We need to create a node, right? And what does node consist of? It consists of a data and a next. And what is this? It is a pointer to next node, right? So this is our node. It has two things. One, we have data, this thing, and this circle is the pointer to the next node. This will point to the next node, to the next list, right? So we need to create a node. We have two variables in it, two things in it, data and a next pointer, right? So let's first create this. uh, we can represent this by a struct, let's say node, and we have a data. And for now we will add like integer values to it, and we have a next over here. Now this is something uh, something good over here. So what we'll do, uh, now why I used a box and why I did an option over here. See, a node, initially a node can be null, right? As I said, whenever we start a node, it points to nothing. It's a like empty node, right? So that is why we used option here, because it can also consist a none value. So by the way, if you are thinking why I'm looking here, I'm like keeping watch on this YouTube chat over here. We can have a null value there, none value there. That's why we take an option, used option in the next variable over here in the. And why we used box? So box is a kind of smart pointer. Uh, so see, linked list, we have to assign it on heap, because linked list changes its size, right? And stack are basically known for those things where we have a known size. So we will assign it on heap because it's dynamic list. Third, a box is a kind of smart pointer. It will keep track of these like dangling pointers and all. So it will make sure that we don't have anything right there, and it will keep also help us to allow use the ownership and borrowing rules without having much to worry, like for us to worry, right? So that's why we are using this box smart pointer. And yeah, so we have our node, right? Now what we need to do is we need to create a linked list, and we have a head over here, right? And what does it do? A head will be an option box and node. Okay, so now we have linked list. We will assign and create instance of these linked list. We will implement everything in this linked list struct. We have a head over here, like we discussed here, like in diagram. Initially we have head, and we will shift this head, and this head is the option and box type to node. All right. So this head is the option, and it has a box type, and it is pointing to this node that we have created, right? this data and this pointer. Okay, so now let's implement a few things over here. So what we are going to do, let me just show you over here. So we'll create something like list, something like this, and we will implement something like list dot push and list dot display. After we push, we will display it as well on the terminal, like how the list is looking. And we will do poop, like what we'll do, push, no, we already have pushed it, so we will display it, and then we will simply write a pop. We will not use like much thing. We'll everything we do push over here, we'll display it, we'll pop it, we'll again display it, just to have an idea that okay, the list is working, right? So we'll do something like this. So let's remove this for now. In order to implement these things, we'll use simple keyword, linked list. So now that we have to initiate a new list, what we'll do is we'll create a function new. Okay, it will return this linked list. Okay, it will return an empty linked list. So link list, and it has a head that will point to none. All right. Okay, that will point to initially that will point to none. Okay, now let's implement push. Okay, so it's expecting a block while parsing this thing. Linked list had none, expected a block. What happens? Let me just compile it. By the way, if you guys are watching this stream, please like it. Okay, so I think we have a signature mistake over here. We need this thing whenever we return something. All right, let's save this. All right, the new has been implemented. So this new function will be used to initiate a new instance of this linked list. So if anyone is watching this stream, please like this stream, share it with your friends, and uh, mm, please do check out my other videos as well if you. Okay, uh, now let's implement push. So what push does is it will take a mutable reference to self, right? And will take a data of type i32, because as I said, we will implement we will first we'll take data as integers. All right, now what does push do? So basically, let me just show you. Where is this scaly draw? So it will, as you can see, there is a node, right? So we have a node, we have a data, and this next pointer. So whenever we add this node, the head gets shifted to this new node, right? So how we'll do that? uh, let's create the current node first. So currently, let me just kind of write pseudocode over here. We have this head. What we'll do is we will shift this head to this new node, right? New node. Okay, and this head will come from self dot head, and we need to create a new node over here, right? uh, because we are using an option over here, so we'll use some new node. So this is the base of push. So head gets shifted, so we have done. Now we need to implement a new node. All right, and what will be a new node? A new node is this, right? We have a data, we'll use shorthand because this variable name and the field name are same. And we have next, and what will be the next? Next will be the self dot head, and we'll take its whenever we use box, we use this take method to get its reference, like. Okay, now this node over here is actually a box type, right? So we'll implement a box over here. Okay, awesome, awesome, thank you. So right? So we have push implemented over here. What we did was we created a node, we shift this head and we use some because it's an option type, right? And this is a box, the node is wrapped in box, so we did a box dot new. We have data and we have next we have took now that it's time to shift the head, so we the next will point to the next node, so we have taken the this reference over here, the self dot head, right? Let's implement display. So why are we implement display here? Because we'll first test these out, right? We'll push it, we'll see, and in order to see we have to implement this display. Okay, self, it will take self because we need to iterate few things over here. So if you guys are watching this, please like this stream and share it with your friends. All right, so how do we display this? So in order to display this, we need to iterate this list, right? So we'll iterate it until we hit the none, and as soon as we hit none, we'll stop, right? So what we'll do, we'll use while loop, right? And while we have to use on this, right? And it will be used on a current node. And how do we fetch this current node? Let's go up. We'll use current as, all right? Now we need to iterate this current. Okay. So what if we didn't encounter any? Uh, okay, we need to handle that case as well. We'll do that here, right? Check if the list is empty. Okay, we'll do that here, but let's handle with if the list is not empty. So if you guys are watching this, please like this stream and share it with your friends. This is a quick stream, it will be very short, and I will end this stream once after implementing this linked list, because I have to, like, I'm running short on time. But if you are watching this on later point of time, please leave comments, I'll love to check them out. Okay, all right, so we have implemented this thing over here. Now we need to iterate this list, right? So what we'll do is we have used this while loop, and we have extracted this current value out of it. What we'll do over here is we will simply use a print statement. Okay, print macro. Why are we doing print macro? Because we want to show it in a single line, right? So node 1 point to next node, point to next node, and then point to none. So what we'll do here is we'll simply use this, right? And we'll use node dot data, whatever we node we get, and we'll simply use current as node dot next, and as soon as this loops over, we'll print none. Okay, none or null, whatever is it. All right, we'll print this now. It is a it says cannot mutate current, right? So let's make this mutable. We'll use a mute keyword, and we have this some node and node dot data and all right. Now we will handle if the list is empty. Now if the list is empty, the current will be none, right? So we'll use if current variable box node global dot is none. All right, we'll simply return from here, return, and we'll print hey, the list is empty. Hey, the list is empty. All right, we'll print this. And so we have implemented a display rate. Let's implement these things. Let's do what we want to do. We need a mutable list over here. All right, we'll say linked list associated functions new. Right, we have our list. Let's say list dot push 12 list dot push 14 list. Let me just make it up here. List dot push 24. Now it's time to print that list, displaying the list after a push, after a few pushes. Alright, what we'll do is we'll do list dot display. Alright, let's check this out. We'll do a cargo build. Alright, cargo run. So as you can see, you see 24, 14, 12, and finally it has pointed to none. So let me just pull a diagram over here that we have drawn. So as you can see, we have initially we have empty list, and once we start pushing in it, the head got shifted. As the new value added, the head points to the new value because that's a head now, because we are like adding in front. All right, so we have this 24, 14, 12, and just like this. Let me just show you by adding few more nodes. Exit. So right, let me just copy this and do something over here like 50, 100, 150. So now as soon as I'm pushing, the most recent push will be at the top, right? Let me just again do this. So how will the list looks like now? You can imagine. So the recent push will be on the front, so it will be 150, 150, and so on, right? So let me just do that cargo run. You see 150, 100, 50, 24. So we are pushing at the front, the head gets shifted to the most recent one. Okay, let's exit it. Now implement a pop over here. All right, we have 9 views. If you are watching this, guys, like this stream and share it with your friends. And in later point of time, if you are watching this, do leave your comment. I would love to go through them. Okay, so we have push display. Let's implement a pop over here. So pop will also like do this. It will take a mutable reference because we are going to edit this. We will return a popped value from here, right? And it will be of type i32 because we are handling integers over here. Okay, and so few things to note. Let's say if the list is empty, let's handle the else case first. So in if we will pop our thing, and let's say list is empty, what we'll do is we'll print over here. Oh my god, list is empty. Okay, we have an empty list, right? Or nothing to pop, and we'll return none because we are returning an option from here. Okay, now this thing. So what if we have something? So this if part will handle that. Now let's imagine how this pop will work. So once we pop anything, let's say I want to pop this thing. Now what we'll do, deleting means shifting this node, the current node, to this, instead of we'll shift that to the next node. All right, so if I'm popping this thing, what I'll do is when I pop this thing, currently it is pointing to this node, so it will be removed, the head will shift to this node. All right, let's do that. And let's do something. Okay, and what it does is, and we have this some node. We'll take a reference to this. We'll use this take method from here. Now what we'll do here, we'll simply do we'll return first of all, let's say the current node that we want to delete is the first node, right? It will pop it from top. So node dot data. This way we will have why we are using sum, because we are returning an option, right? Now what we'll do is we will use self dot head. It will shift to node dot next. Does that make sense? The head gets shifted because we have removed the first element. So deleting the first element means we are kind of isolating it. So if I go here, so if I delete this, currently head is pointing to this node, right? Once this is popped off, it means the head, we will shift the head to this node. So now that we will read the list, it will read from the head and it will not read this node, and it will be popped. And that we have, and now that we have used box pointer, it will take care of like this references thing and all. So this pop has been used. Now let's implement, let's see how we can print pop over here. So if I do this, so we'll use, let's say we have a node over here, right? And what we'll do is we will use list dot pop. It is returning us something, right? And if we have else over here, we'll simply use println. So if you guys are watching this stream, nothing to pop, list is empty. So if you are watching this stream, please like this stream. Print ln. What we can do here is popped value will show what the value we have popped, and that value will be node, because we have written node dot data from there. Let's implement a semicolon here. So that now we have implemented push, pop, and this. After popping, let's do display over here. Let's yank this. After pop, let's update this to pop list dot display. What happened? What happened? All right. So yeah, I think my CPU is going. Power is not there. So guys, this is the time we have implemented like push and pop and all. So this is the linked list, and what you can do over here is stream ended.